Hello everyone, myself Anurag Mondal, Assistant Professor of EC Department. Welcome to the series of lecture of digital system, and today I'm going to discuss with you regarding the number system part number 2. So in this session, I'm going to discuss with you regarding the following contents. These are the last class overview, then motivation, the conversion from the decimal to binary, octal and hexadecimal. Then what about the general rules for conversion of decimal number to any other number system? Then we move towards the decimal number system conversion from binary, octal and hexadecimal. And at the end, we move towards the general rule by which we can convert any number system to the decimal number system, and we conclude our session with some quiz questions. So let's move on. What we learned in the last class, that is the number system part number 1. First, we have learned about the importance of number system in computer. I have shown you some images where some data is stored over a memory location, and there the memory location is there the data is stored in terms of hexadecimal number. Okay, and that hexadecimal number we need to know what its meaning, then only we are able to design any kind of memory, and that is why the number system is very much important in the computer. And moreover, the octal number system, binary number system also important in the computer system, because all the signals are moving inside the computer are the digital signals. Okay, binary signals. Now we have learned about the definition of the number system. What is the number system? That number system is nothing but the representation of any number. Okay, next, the type of the number system. We have shown you the 4 types of number system: binary, decimal, then octal, then hexadecimal. These are the main 4 number system. Okay, other than these 4, there are so many number system present in our real world. Then uses of each number system and their counting, how we can count the octal number system, how many numbers are present within the octal number system, and the same as it is for the hexadecimal number system. Okay, then we are discussing about the application of each and every number system. Then I just shown you the other number system table. What are the other number systems are present rather than this 4, and how we can represent those other number system like this. So we have already discussed this thing in the part number 1. Now today in the part number 2, we are going to discuss regarding the conversion of the number system from decimal to binary, octal, hexadecimal, and from other number system to the decimal number system. Now about the motivation, again I am showing you the same image. Okay, now in this same image you have to see that this 0a is over here, but this 0a is a data in the memory particular memory location. And as I discussed yesterday, all of we know that whenever some data is stored within the computer, that data is stored in terms of 1010. Okay, then that 1010 is represented in terms of 0a. So we need the conversion between each number system, then only we can represent any kind of number system to any kind of number system. That is why our today's lecture is most important part of the number system. Okay, now let's move on to the main series. First, is the decimal to binary conversion. Now, what we supposed to do? We need to convert some decimal data, that is the 45.125, that is base 10, to the binary equivalent number. So we need to follow some step to convert this decimal number to the binary number. What are those steps? First steps, divide this number into two parts. One part before the decimal point, another part after the decimal point, and with the decimal point, that is the along with the decimal point. So I want to mean this thing. The first part is consist of 45 and second part is consist of 0.125. Next step is, first part we have to divide with the base of the number system to which we need to convert. Okay, now here we need to convert the decimal number system to the binary. So the first part we need to divide with the help of the 2 and kept the reminders. Keep on divide. Next step is, the second part, keep on multiply with the number system base to which we need to convert. We need to convert to the binary. So we need to multiply the second part with the base, that means 2, and from the result separate the left side part and keep on multiplying. I will show you what I'm going to tell you within this 3 step. So we have the number, that is the 45.125. So we need to convert this number. This number is in the decimal. We need to convert this number. Okay. The first step is to separate into first part and second part. This is the first part. Okay. And this width point, this is the second part. Second step, we have that first part we need to divide with the base of the number system to which we want to convert. We want to convert to the binary. So we need to divide the first part with 2 and keep the reminders. So we have the first part, that is the 45. We need to divide this part with 2. Okay. So after dividing, we have 22 and we have reminder, that is the 1, and we have to keep this reminder. Next, again we have to divide. We have 11, reminder is 0. Again we have to divide. We have 5, reminder 1. Divide 2, we have 1, reminder. Again divide 1, 0. So we need to keep on divide until the last number is less than the base of the number system. Okay, with which we just divide. So here 1 comes, that is less than the 2. We just stop the division. Now we just keep the reminders. So how we can represent the 45 with these reminders? We need to go from the bottom side to the upward side. So 45 we can represent with the help of 1, 0, 1, 1, 0, 1. That is the binary equivalent of the 45. Now, third step, here, second part, we have to multiply with 2 because the binary conversion we want. So we need to multiply with the base of the number system to which we need to convert. So, and separate the left part and keep on multiplying. So we have 0.125. This is our second part. Now, first we have to multiply with 2 as the step 3 suggests, and it is equivalent to the 0.25. Left part means the left part from the decimal point. What we have? 0. So keep 0 here. Now what we have? 0.25. Now again multiply with 2. We have 0.50. What we have in the left side? 0. Now again we have to multiply 0.5 into 2, that is 1.00. What is at the left hand side, left side of the decimal point? 1. And if 1 is separated, we have remaining what? 0.00. So whatever we multiply with 0.00, we have only the 0 value. So we just stop multiplying. So what we have? 001. So the 0.125 is nothing but the binary equivalence of 001. So how we can write this 001? So we have to write from the upward to the downward. So we have 0.001. So this is the binary equivalent of the above decimal number. And that is within the 3 steps I just shown you. Next, decimal to octal. We have the decimal number with base 10. Next, first step, again the same thing. We have to divide this thing. First part, left hand side of the decimal point. Second part, right hand side of the decimal point along with the decimal point. Okay. Now, again the step 2, that is we have to divide the part number 1 and keep on divide. Step 3, we have to multiply the second part with the base of the number system which we want to convert, that is here the octal number system we want to convert from the decimal one. So we need to multiply the second part with the 8, the base. Now the results, in the results, separate the left side and keep on multiplying. So I just shown you what I want to tell you within this 3 steps. We have the 75.25. Okay, so let me write down here 75.25. So this is nothing but a decimal number. We need to convert it into the octal number. So what we suggest that we have to first divide, that the first part is 75, second part is 0.25. Now as the step 2 suggests, we need to divide 75 with 8. So what we have? 9, 72, 75 minus 72, we have 3 over here. So now again we have to divide with the 8 because 9 is greater than the base. So we have 1, 1. Now the equivalent octal number of the 75 is this reminders, and again in the same way we have to start from the bottom and going towards the up. So we have 1, 1 and 3. So Now in the step 3, we have to multiply 8 with the second part. What we have in the second part? 0.25. So we need to multiply with the base to which we need to convert. We need to convert from decimal to the octal. Base is 8. So after multiplication, what we have? 2.00. So separate the left hand side, means if 2 is separated, the remaining part is coming over here. Then if you multiply with the 8, we have only 0, 0. So stop multiplying. So the octal equivalent of the 0.25, we have only 2. Now how we can write from the upward to the downward? So we have write down here only 2, 0, because if we write down some 0 over here, that 0 doesn't have any meaning. Whatever we just multiply with the 0, that becomes 0. So the binary octal equivalent of the 75.25 is the 113.20. That is the octal number. Let's move on to the next thing. That is the hexadecimal number, that is from the decimal number. Same thing, we have the same number, decimal number. So how we can convert? First step, the same thing, we have to divide the whole decimal number into two parts. First part, before the left hand side of the decimal point. Second part, the right hand side of the decimal point, and we need to we need to take the decimal point also with in the right hand side, in the second part. Okay, now the second step is same here. We have to divide the first part with the 16 and keep the reminders and keep on dividing. Same way, the third step is we have to multiply with the base of the number system to which we want to convert. We want to convert into the hexadecimal. So we need to multiply the second part with the 16, and whatever the result we have, we just keep the left part and keep on multiplying. So let me show you how these three steps are going for conversion of decimal to the hexadecimal. Our number is 75.25 and this is a decimal number. According to the steps, first step, we have to divide into two parts. First part, left of the decimal point. Second part, the right of the decimal point along with the decimal point. Okay. Now, according to the second step, we need to divide the first part with the base of the number system to which we need to convert. We need to convert into the hexadecimal. So 16 over here, and 16 4 ja 64. So we have the remainder 11. Now the hexadecimal equivalent of the 75 we got as the remainder. Okay, so now from the downward to the upward, in the same way what we have done into the other two section. So for the 75 we have 4 and 11, but in the last session I have discussed with you the hexadecimal number system, and within the hexadecimal number system, after 10 what we do, from 10 to 15 we have to replace that 10 to 15 with A to F. Okay, so we have the 11, so we never write the 11 in the hexadecimal. We have to write in terms of A, B, C, D, E and F. So what is the equivalency of the 11? We have 10, that is equivalent to the A. We have 11 that is equivalent to the B. So we need to write down B over here. So that 4 as it is should be there, then B should be there. Okay. Now, according to the third step, we need to multiply the second part with the base of the number system to which we need to convert. We need to convert to the hexadecimal. The base is 16. So 0.25 multiply with the 16. So we have what? Only 4. 0.25 into 16, only we have 4. So 4.0, separate the left part, means after separating we have only the 4, the remaining part will go over here and keep on multiply with the 16. We have 0, then we have to stop here. Okay, so what we have the hexadecimal equivalency of the 0.25, that is the upward to the downward, we have the 4. So what we have 0.40. So that is our hexadecimal equivalence of the decimal equivalence of this number. So we have just till now we have just covered the decimal to binary conversion, decimal to octal conversion, and decimal to hexadecimal conversion. And if we look carefully, all the three conversion having almost the same rule. We need to divide into two parts if there is a decimal point. Okay, now left hand side of the decimal point one part, and the right hand side along with the decimal point is the another part. First part we need to divide with the base of the number system to which we want to convert, and for the second part we need to multiply with the base of the number system to which we need to convert. So we can find out a generalized way, that is the generalized rule for the decimal to any number system conversion. So the first thing, whatever the number we have in the decimal, we need to convert to the other number system, and for this we need to follow the following steps. First thing, divide into two parts as I just told you. Second step is the divide the first part with the base of the number system. Okay, and keep the remainder and keep on divide. Third step is that we need to just multiply with the base of the number system to which we need to convert, and just separate the result and keep on multiplying. So if I take this thing with some example, so I just shown you some example. Okay, so that will be the better way. Okay, now so we need to convert, for an example, that 16 167.45, it is in the decimal number, and we need to convert it into the equivalent 9 base number system. So what we do, first step, this is the first part, this is the second part. First part we need to divide with the base of the number system to which we need to convert. We need to convert into the base 9 number system. So we have 167, and that 167 we need to divide with 9. So 167, if we divide with the 9, what we have? Then we have the 18 over here, and if we multiply the 18 with this, we have 162, and once 167 minus 162, we have the remainder, that is the 5. Now again we have to divide 9. 9 2 ja 18, so we have the remainder 0. So what we have, 205 only, because we have to count from the downward to the upward. Now for the next part, we have 0.45, and we need to multiply with the base of the number system to which we need to convert. So if we multiply with 9, what we have, the 4.05. Separate the left hand side, separate 4 over here, and keep on multiply. So what we have, that is the 0.05. Again we have to multiply with the 9. So 0.05 multiply with the 9, we have the 45 again, 0.45 again, and we have the 0 over here. So separate the left hand side, and remaining part we have to multiply again. And again the same thing, we have the 4.05, and after separating 4 we have the 0.05 only, 05 only. So this is repeating. So what we need to do, just after 3 we just stop over here, and what is our equivalency of the 0.45 into the 9 days number system, that is a 0.404. That is the rule of the generalized thing. Okay, now move on to the next part, that is the binary to the decimal. For the binary to the decimal, what we do, for the binary to the decimal, first step, we need a binary number that we have to convert into the decimal. So first step is divide the number into the two parts again. The left part is before the decimal point, and the second part is after the decimal point, but here we doesn't take the point, decimal binary point over here. Okay, now the first part is the left hand side of the binary point, second part is the right hand side. Now in the step 2, we need to write down this first part and the second part in terms of weighted form and add them together. We have the decimal equivalence. Remember, in the last session, I have shown you how to write down any number system into its weighted form. Now we need to write down this particular first part and the second part into its weighted form, and after addition we got the decimal number system. So what we have, that is 10110. So if I write down into the weighted form for the first part, so what we have, 0 into 2 to the power 0 plus 1 into 2 to the power of 1 plus 1 into 2 to the power of 2 plus 0 into 2 to the power of 3, then plus 1 into 2 to the power of 4. So ultimately what we have 0 over here, plus we have 2 over here, we have 4 over here, we have 0 over here, plus we have 16 over here. Okay, so ultimately what we have, only 22. 16 plus 4, 20 plus 2, 22. Now for the second part, if I write down into the weighted form, just keep it in mind, second part is after the decimal point. So if I write down into the decimal into the weighted form, what is the weighted form at that time? 0 into 2 to the power of 0 into 2 to the power of minus 1 plus 1 into 2 to the power of minus 2 plus 1 into 2 to the power of minus 3. So what we have, 0 plus 1 upon 2 to the power of minus 2 means 4 plus 1 upon 2 to the power of minus 8 means 1 upon 8. And if I divide all the things, then we have 0.25 plus 0.125. So ultimately we have 573. That is the point. And after 22 plus 0.375, we have what? 22.375. And this is the decimal equivalence of this binary number. Same, octal to decimal, we have the octal number. First step, divide into two parts. Left hand side of the octal point, right hand side of the octal point, but here we doesn't take the octal point. Same way, 75, 23. Second step, express everything into the octal. So 75, what we have to write? 7 into 8 to the power of 1 plus 5 into 8 to the power of 0. Okay, now what we have? 56 plus 5, then we have 61. Now for 23, what we do? 2 into 8 to the power of minus 1 plus 3 into 8 to the power of minus 2, and like that we have some number, and after addition whatever the result is, that result is the decimal equivalent of the octal number. Same way for the hexadecimal to the decimal. Hexadecimal number we have, and we need to convert this hexadecimal into the decimal one. First, we have to divide into two parts. First part, second part. We never take the hexadecimal point over here. Okay. Now the step 2 is write down first part and the second part into its weighted form and add them. So A and C. A means what? A means we know that is the 10, and C means we know that is the 12. So what we have to do? That 10 into 16 to the power of 1 plus 12 into 16 to the power of 0. Okay. Now what we have? 160 plus 12. Now we have 172. Same way for the 23, what we do? 2 into 16 to the power of minus 1 plus 3 into 16 to the power of minus 2. Whatever the result we have, thus add that two result, the first part result and the second part result, we have the decimal equivalent of this hexadecimal number. So if I just rewind all the things from any number system, that is from binary, octal and hexadecimal to the decimal, all of them have the same rule. First, whatever the number system number we have to convert it into the decimal, first we do what? We have to divide that number system, first part and second part. Second step is we need to write down each part into its weighted form and addition. So we can say the generalized rule, take the number which we need to convert into the decimal, first part divide into two parts, but here we need to discard that decimal point or octal point or binary point. Next, express that two part into its weighted form and add all of them. We have the number system. Okay, so this is all about today's class. So what we learned today we learned a very interesting topic. Okay, the first is the importance of the number conversion. Okay, that memory part I have just shown you, that memory part, and that memory part we have the hexadecimal form. The data is in the hexadecimal form, so we need to know the binary to the hexadecimal conversion, then only that particular data we can recognize. So we need the binary importance of the conversion. Next, decimal to binary, octal and hexadecimal conversion with an example. Then we have the generalized rule. From decimal to any other number system, what we do, divide into two parts. First part, we need to divide with the number system. Second part, it consists with the point, and we need to divide with the base of the number system. And we have the decimal, we have that particular number system which we need to convert. Next, from binary, hexadecimal and octal, we need to convert, we just learn how to convert into the decimal. Okay, and I have just shown you with the help of the example. Then we have the generalized rule that in any number system, how we can convert any number system to the decimal number system one. So what we do, we just need to just divide that particular number system and write down that both the part into its weighted form and add all the things. We have the decimal equivalent number of from that particular number system. So these are the most interesting and the important part we have learned today. In the next part of the number system, we need to learn conversion of the from one number system into another number system, means binary to hexadecimal, hexadecimal to binary, then octal to hexadecimal, hexadecimal to octal, and any number system to the any number system, one generalized formula. Okay, so quizzes. Now you have to find out these conversion, and after conversion, you just write down here 8, and after conversion we need to follow each and every answer in the live sessions. Okay, so that's all about today's session, the number system part number 2. So keep on watching, that is the part number 3, number system part number 3, and that part number 3 having some very important and the interesting concept for the other number system conversion. So that's all about today. Thank you.